I'm not.
Yeah, they put higher level stuff on it. Great. So implicit differentiation. What is this useful for? Okay. I don't think we've had to do this so far because every one of the functions we've taken the derivative of has always been like y equals.
Yeah.
F of x equals. They've all been explicit, so we haven't had to worry about that. What kind of a mathematical object, like a graph, would not be like y equals?
If it equals.
Can you give me an example?
A
A what? Think simple.
What about like an
This is not hard.
An arctangent?
Maybe. Think of a simple mathematical formula that doesn't say y equals.
y
squared plus x squared
Oh.
equals
A squared plus b squared
Which
equals
is
c
a what?
squared.
a circle.
Or an ellipse, right? A circle
Does
or an
that
ellipse.
count?
How do you take the derivative of a circle or an ellipse?
I don't know. How do you do it?
I know. Does that not count?
using
Like
this.
this.
Okay.
So,
the best idea.
bit of notation. I want to see that problem now.
Oh, I'll give it to you.
Okay, so when we take this derivative of x cubed with respect to x, what we do is, 3x squared, right? Use our power rule. And technically the chain rule says what?
Times 1.
Times 1, but what times what? Times d. And what is the inside of that is just x. And dx, that's 1. That's technically what it says, right?
Okay.
So we get our 3x squared. So what if we have d dx, the derivative, when I see this, I say the derivative with respect to x. Real soon here we're going to be differentiating with respect to especially time. There are all kinds of things you can differentiate with respect to. If you're working in multidimensional land, there's more than 2 dimensions, so you have to think about which way you're differentiating. It could be that way, that way, that way. There's all kinds of different ways. You can use time, you can use heat, you can use crazy stuff. Okay? I'm differentiating with respect to the position x. Now let's say I do it with y cubed.
It's impossible.
Well, it's very simple. You do the same thing. You go, okay, power rule
3y squared
times what?
dy over dx.
You're taking the derivative with respect to x of what? You're right. Of y. That's not just 1 anymore, is it? How can we rewrite this with Newtonian notation?
That's a fun one.
What's the answer? The derivative of y cubed is, with respect to x, is 3y squared plus oops times what? What is dy dx?
Wow.
Y prime. So if you're differentiating with respect to x and you do it with y in there, what does the chain rule always give you?
Y prime?
Y prime, which was different than when we did it with respect to x of something with just x. That was just 1, right? But if you're doing it with respect to x and it's a different variable here, or if this was like z,
Would it be z prime?
then it'd be z prime.
So, isn't z prime what we have right there?
What do you mean?
Isn't it like the 3? Sorry.
What I'm saying is before when we had this problem, we just ignored this. We just said it's 1. Some of you guys were really focusing on, oh yeah, there's a times 1 there, which I really like. But now we can't just ignore it if we've got different things here. Okay?
But what can you figure out what z prime is from that?
Yeah, z prime is the tangent line at z.
Yeah, but do you know that? Like, from what's on the board?
Good question. So let me give you another couple problems, and you'll
Okay.
see. Good question, Austin. I see what you're saying. Let me show you something else, and you'll have your question answered. Okay. So let's do a couple examples. Let's find the derivative of each one of these, and I think we'll use Anna's example. She said a circle. I'm picking the radius to be 3.
It isn't equals to x.
Squared plus 4y squared.
Okay. And on this one, I think just for grins, maybe on this one we'll find a tangent line. So we'll find a tangent line, and let's do it at, I gotta pick something that's actually on the circle. So I'm gonna pick in the second quadrant negative root 3 and root 6. Is that for sure gonna be on the line? Why'd I pick something so strange?
Negative 3 plus 6.
Negative 3 squared is
3.
3.
square root of 6 squared is 6. Does that equal 9?
Yes.
Yeah, that's on the
A
circle.
squared plus B squared equals C squared.
Yes, thank you, Austin. Okay, so let's find the derivative implicitly. So here's the process. I believe I, in pre-calc, said that you might need this kind of a thing, because we have done this kind of algebra before. So one function times another function. What do you guys think I have to use? We've got f times g.
Product rule.
Product rule. So I'm going to go first. What's the derivative of y squared?
2y.
2y times y prime.
Oh, we gotta remember the y prime. We could write that as, I like to write dy
I thought it was
dx.
Okay, it was separate.
First derivative of second. I like to use this notation. It really tells me there's something different in there. I like that. Plus, I'm not done with this
Y
guy yet,
squared.
right? Y squared times
1.
technically 1.
Wait.
That's all product rule, just this guy.
Then would you do plus 5 dy dx?
We're taking the derivative of all sides. We're thinking now of derivative as another type of function operation. I can multiply both sides of an equation by 2. I can take the square root of both sides of an equation. I can take the logarithm of both sides of an equation. I can take the derivative of both sides of an equation. It is another type of operator. So now I go plus 5. Now what's the derivative of y? dy dx. Or y prime, right? You can write y prime there if you like.
Equals 2.
And what's the derivative of this with respect to x?
2 times.
2.
So, did you figure out? Oh, because the 2 is.
Is the y squared
Oh.
because the prime of 1?
I'm going to call this first. Second prime. This is the second. And that is the first prime. There's that product rule. Okay?
Got it.
So now I can simplify. The whole point was, what do I want to do? Just like before, I want to find y prime. So what am I solving for? Y prime, which is dy dx, however you want to say it. I need to solve this for dy dx. So if you've got stuff that doesn't have dy dx in it, I see that term doesn't, right?
Yeah.
Chuck it to the other side. So I've got 2 minus y squared on the other side. Do you guys see that? Anything that doesn't have dy dx, move it to the other side. Anything that does, keep it over here. So now you've got 2xy dy dx.
Wait, don't you
And
have to
you've got a
distribute
plus
the x
5
to
dy dx. It's all multiplied.
that? Oh, yeah, okay.
Factor it out. So 2xy plus 5. What do you guys think the final step is to get dy dx? Fine. So the derivative of that implicit equation is this.
Oh, that makes sense.
Would it be possible on this equation to find dx dy? Yes, it would.
So you're finding x in respect to y? Is that what that would be
I'm
saying?
finding the derivative of y
In
with
respect
respect
to
to
x.
x.
Yeah, no.
Could you do it the other way?
The
I'm
other
asking.
way.
Sure,
Yeah.
you could. You definitely could. Maybe we'll see that. I'm not going to today. It will confuse you. Okay, you certainly could though. So let's do it with n as circle. I think this one's not too bad. What do we got? Derivative of that?
2x.
2x
Plus 2y dy dx
plus 2y dy dx
equals
equals
0.
0. So that can be pretty easy to solve for the derivative. Yeah. Do it one step.
Why did it go to 0?
It's constant.
Okay.
It's fine. Negative 2x divided by 2y, which is
X over y.
negative x over y. There's the derivative.
And then your tangent line.
And then I asked you, okay, draw the tangent line. Circle is radius 3. That point is like over here on the circle, isn't it? Like somewhere right there. Wait, okay? So I'm looking for this tangent line. Looks like it's going to have a positive slope, doesn't it? So if we do that, let's use our nice notation. dy dx evaluated at negative root 3 root 6. Notice this
You
notation
have
is
a
nice here.
y and an x, so you can plug them both in.
Do I need an x and a y this time? I do. This derivative depends on x and y. That's why this notation is so nice. You can't do it with the prime notation.
Wait, so it equals
Root 3 over root 6.
Negative root 3, right?
It's positive because that's a negative root 3 in there, and that's a negative x.
Which is some kind of decimal,
Yeah.
right? We could get the decimal like Anna
Why
was
would
saying
you
earlier.
bother?
It'll be fine. I'm just going to write down the tangent lines. So we'll go y minus
Root 6.
root 6. Somebody else?
Root 3 over root
Okay, somebody else. Plus root 3. Now what? Somebody else? Running out of people.
So then you have
Distribute.
y, so it's y
Okay, distribute.
equals root 3 over 6x plus 1 over
3 over
We got a plus root 6, right? What else we got? We got to distribute that part, right?
yeah.
So, you
So
have
root 3 times root 3 is
3.
2 root 3.
this should be a root, shouldn't it?
Yes.
There we go.
That should be a root down there too. Mr. McGee, next to the x. Thank you.
Fancy. So that might be a good one to use decimals in your calculator. We could see it on the line. Oh, by the way, remember that one where we did the normal line the other day? We tried to get the perpendicular. You know why it wasn't working? It was just the window.
Oh.
Like I had the window so stretched, one slope was like super steep at 80 and the other one was like negative 0.01. And the way that I had the window set up, it looked like this wasn't the same as this. And it just didn't, it would have looked perpendicular if you had the nice window on there. It's hard to get a window on that problem. Should have done it beforehand to one. Okay, let's do number 3. Then maybe stop there, I think, for today. Oh, let's do a different one.
Number 3 is exactly
Let's leave that till
like
tomorrow. It's like the same thing.
Erase?
Yeah, leave it. Leave some space for tomorrow.
Yeah, I'll leave that tomorrow.
It's a good warm up for tomorrow. Let's do this one. How often do you think in the real world, like in applications and stuff, this is used for? You might have mixtures of variables, mixtures of
Often.
positions and times. I'm thinking
A lot.
most real world problems are implicit. Okay, so this one's got a mixture of x and y, right? Let's take the derivative. Think of it just as operating on both sides, right? You just take the derivative of everything. Just like what you've done before. So I take the derivative on the left, what I get?
dy dx.
dy dx. I'm going to write it as y prime this time. You guys cool with that?
That's fine.
Okay, then I'm going to take the derivative of that one.
Cosine.
Cosine of, leave it alone. Some of you are still not unchained while leaving it alone.
And then times.
Times 1 times.
Times the
Oh,
product.
prime.
Inside we've got a product, right?
Oh, yeah.
So first, derivative of second, plus second, derivative of first. Should really do that in red. Right? There we go. Now once again, am I done?
No.
I'm trying to do what? I'm trying to find the derivative
Y
of
prime.
y with respect to x, y prime. So I need to solve this for y prime, so what should I do?
So you do subtract.
Well,
Subtract this, you mean? Sure.
what would
If
you
you want, this is
suggest?
basic algebra. I give this to algebra 1. Have weird symbols in it, but
I
Don't
pulled
make it
that
hard.
out. Distribute.
distribute, yeah, just distribute. Break it down to its most basic components. In mathematics, honestly, until I took abstract algebra 400 level class, I really still didn't understand how to break things down to their basic stuff and build back up. It's such a powerful thing. It takes a lot of experience. Distribute x, y prime, cosine. Then also plus
Y cosine x.
y cosine. That one has a y prime in it. I'm gonna move it over there.
One minus x cosine
cosine. Equal stuff. Doesn't matter how complicated that stuff is, it's stuff.
Oh, never mind. Okay, I see what you did. You okay there?
And finally,
Divide.
divide. So on these kinds of implicit problems, what you really need to do, break them down to their most basic things. You might have 3 y primes in there. It doesn't matter. Move them one side, factor it out, you're done.
Almost. Well, I should have.
Okay.
What?
Can our calculator graph this?
No.
It can't, can it? No.
Unless you're
Unless,
cool,
just
right?
Your calculator only accepts explicit.
Are there
Doesn't
What
accept
about
these kinds of
polar
things.
land?
Oh yeah, software will do this for sure. What's this look like though? I think it'd be strange, something we've never seen.
It's infinity.
So sometimes looking at something isn't necessary. This is using the
Mr.
analytical
McGee,
side.
are we having class on Thursday? Because I'm really confused about what's going to
No,
go
I don't
on.
think so.
Nope.
Nope.
Because it's Survivor Day.
Okay, I'll do 1 or 2 more tomorrow, but you're definitely set. So here's what we're doing.
And then that worksheet also.
Yes.
Just take these paper notes really fast.
Just go home and sit.
Like jump down and like do what? Sit in my room.
Okay, I was gonna make this due on Thursday, which I totally have 100% right to do.
Except for we
But I'm
don't
trying to
have
help you guys.
Tuesday.
So this is basically due Thursday. You need to have it pretty much done. But I'm not gonna make it due until next week sometime. I'll collect this and our final assignment from this chapter together. Okay, so if you absolutely need some more time on it this weekend, you can do that. But you need to honestly have it done by Thursday if at all possible. Okay? That way we can also this weekend when we have our little study session, if we need to look at a few of these, we can. That means worksheet.
Okay.
And the
Yeah,
worksheet?
I think
Yes,
I'm
and the worksheet. Just to give you perspective, when they do things at South, those would be assigned and it would be due tomorrow. Now they don't have as many classes as us, they're on a block. This would
I
be
think
assigned
it'd
and
be
it would be due
nice.
tomorrow, and the next day
I
would
would
be
like
another
South
assignment
first.
and it would be due the next day,
What is that last name?
and it would be just as big.
Worksheet.
So,
Oh, worksheet.
perspective. Consider yourself fortunate, right?
Yeah.
Now, not very many people survive that, but
What would you recommend doing the worksheet or the assignment first?
doesn't matter. I think I gave you a bunch of odd problems at the beginning, so you could check yourself. So I did that.
Those are actually quite nice.
Yeah,